designing, manufacturing, installing, and maintaining the high-speed electronic computer, the largest and most complex computers ever built.
Hello, everyone. Welcome to the Building Better Systems podcast, where we explore tools and approaches that make us more effective engineers and make our software safe and reliable. My name is Joey Dodds. I'm a researcher focusing on providing assurance for industrial systems.
And I'm Spat Morina. Joey and I both work at GAWA. GAWA is a research and development lab that focuses on high assurance systems development, and more broadly, just hard problems in computer science.
And today we're joined by Gene Young. Gene has one of these resumes where if you made it up and then showed it to someone, they'd be like, "You made that up." That is the prototypical excellent PL researcher resume. That can't be real, but that's Gene's resume. Even though that's Gene's resume and it's really impressive, it's not what I find to be impressive about Gene. What I think is really amazing about Gene is that through all of that, she kept an incredible focus on the problems that were important to her and realized that world was not the right world for her to be doing the work that mattered to her. And so today we're going to talk about, we're going to go over that with Gene and discuss what that work is and why it's so important and how she's starting to take a bite out of the huge problems that she's going after. Thanks a lot for joining us, Gene.
Yeah, thank you, Joey and Strat. Yeah, thanks for the very kind intro.
Yeah, well, I think you deserve it. So yeah, I wanted to start off by asking, what is your approach to building better systems?
Yeah, absolutely. So I am kind of a strange PL person because maybe all PL people have these two parts of themselves. They have the very principled how things should be, the idealized platonic version of systems where, I spent a summer programming in Boogie, which is basically like Pascal with preconditions and postconditions. And I was like, oh my God, I feel so clean now. This is how everyone should program every day. It's the equivalent of like waking up, like flossing twice a day, brushing your teeth after every time you eat, and just like living this like pristine, perfect life. And then there's this other side of me that's just like, look, we got to get shit done. And so I have a blog post, I think from 2013, where I talk about how, so for my PhD, I made this I made this language for automatically enforcing privacy policies, and then I implemented it as a domain specific language. And in 2013, I switched that implementation to Python. And so I don't know what degree of PL nerd someone needs to be to realize how far away from PL nerd Python is. But there's your Haskell, your Idris, your like very nice, strongly statically typed languages. And there's Python. And Python is just like very practical, dirty. There's like XKCD comic. You can just fly when you use Python. And for me, I was just like, this is amazing. I can get stuff done. There are no guarantees. The language has no semantics that are documented that anyone knows of. That it definitely has no meta theory, but you can just get stuff done. And so I wrote this blog post in 2013 that was like, I'm using Python now, guys, and I compared it to being like the vegetarian grad student who considers chicken a vegetable because that's what they have at free lunch. But like on the one end, I think I'd love to have guarantees for all of our systems. I would love it if we knew what was going on all the time. And on the other hand, I think we just need to ship lots of code into the world because that is how we make an impact. And so a lot of my career has been trying to reconcile those two sides of myself. How do we take these really nice ideas from formal methods and then bring them to the people who are like the other part of me, who are really passionate about just building stuff. Like if you ask me what I program in on weekends, it's Python, guys. It's like not even Python with classes. It's just like scripts. It's like copy pasta, like me, like just like taking hard coded about like there's like some stuff I'm just like, I've got 15 minutes. I need to get this done. And like, it's ugly. And I think that I don't know, maybe other PL people don't do that, but definitely I've never heard another PL person really admit that.
I want to clarify, when you say PL person, it's programming languages.
Programming languages,
Okay.
yeah.
So if I might recap, your approach to building better systems sounds like it's focused, making sure that you're focused on the building part of it.
Yeah, I'm very interested in building, and I want to make sure that no matter what kinds of tools we build, for making the systems more robust, for making them more secure, for making sure that we actually know what's going on in the systems, we never leave behind the people who just want to build and who just want to build as quickly as possible, because there's always been that side of me.
Yeah, I think that's great. I think and it's a really rare combination. And especially after you spend so much time in academia learning the ins and outs
Yeah.
of so many of these really clean systems that they feel great, right? Like you said,
Yeah,
they
yeah. No, it's just like you feel like you're gonna go to software development heaven or
yeah,
something
you
for
you know
sure.
the problem, you get it done. It's like problem sets kind of, but like you get to do that
Yeah.
forever, and it keeps getting harder and harder.
Yep, yep,
Um,
yep,
but
yep.
like
Yeah, it's very
to
addictive.
go that deep into that world and still say we got to stop, we've got to figure out what of this can cross over today.
Yeah,
That's hard, but it's
absolutely.
really important.
Often, not always, but often when I talk to people that are kind of into formal methods and those things, sometimes these two worlds seem to be um, kind of incompatible in terms of, like, if you're building stuff on with languages that don't necessarily provide some of those protections or don't allow you to apply some formal methods, then maybe some people will be like, well, are you really building systems that are better, for some definition of better? Just curious about, like, your how, how you think about that.
Yeah, no, that's a great question. And I think this yawning divide between formal methods and what people mostly use in practice is what I've been going after closing for my whole career. And here's the way I look at it. So I first started thinking about this after junior year of college when I took programming languages. And I fell in love with functional programming. I fell in love with semantics. I fell in love with types. And to me, it was such a revelation that we could actually make sense of the mess that is software. And then I go off to Google. And that summer, they're rewriting the video search front end from Java back to C because they can't afford the 50% memory overhead. I try to strike up conversations with people about functional programming. I just get mocked. And so I would write to my professor every week and be like, hey, man, you taught me some stuff, but it doesn't seem to be in practice here. And what I realized was a lot of the people who are working on this is how programming should be. They were a ways away from the people working on what programming is, and it was, it's two different groups of people, two very different mentalities. But I think in the last years it's been closing a lot, and so I think that gap is closing. I also think that compute has become cheap enough that a lot of the software verification, software analysis tools can actually be practical now on programs that are longer than 10 lines. But I do think there's a huge remaining gap, which is most of the work in formal methods has been done assuming like a pretty monolithic, classically architected system where you have your assembly, you model that assembly, you have your next level up language, you model that, and then like you kind of layer on top of that until you get to like your whole thing. And so if you're building like NASA spaceship software, like that's probably
Right.
fine. They're probably still doing it that way. But if you look at modern web applications, oh my God, you have this massive heterogeneity of the software environments that things are running in. You have this massive heterogeneity just like throughout the whole tech stack. You have, different language frameworks that everything is running in, different kinds of machines. You're running in containers, you're running in all this stuff that, how do people even model that? And then what's more is then you have everything talking to each other across the network. With remote procedure calls. And so this is stuff that typically no one modeled because we haven't gotten there yet. It's a combination of we haven't gotten there yet, and no one in academia is really programming systems that way in programming languages. But to me, the really interesting question is how can we take ideas from formal methods and actually tame this world? So massively multi-service, massively heterogeneous in terms of the tech stack and all of that. And how do we actually bring order to that?
How do you?
Yeah, that's a really good question. And so My view there is that we can still have formal models, we can still have nice guarantees, but we are not getting them by starting at the assembly. We have to start at a much higher level of abstraction, and these specifications are not coming from programmers. They need to come some other way. And so, how a lot of modeling typically works is someone spends, 1 to 20 years modeling x86. They're like, all right, guys, we've got this model of x86. Now let's model the next level up, and let's go one layer up at a time. And how how I think we really need to handle things in this new world is I'm really in love with the API layer. So I think that all of these massively multi-service things, there's APIs that they call each other from. That is clean, that's well defined, everyone has them. We should really start thinking about that. Not the applications inside, but really that's the layer of abstraction that's really interesting to me if we're talking about these ecosystems of software here. And how we're getting specifications and any kind of model there can't be from programmers, but we need to get them from some kind of software analysis. But yeah, I think the API layer is really interesting for this reason. And I think how we're going to get order to the API layer is software analysis tools. So I'm really excited about black box analysis tools like fuzzing, things like quick chick, or Benjamin Pierce has this latest one that where he even like it's some other thing and then chick, but it really evolved. But things that take software, treat it as a black box, and then try to shake guarantees out of it um, by testing and other kinds of non-traditional formal methods approaches.
So I wanna ask you a little bit about, you said like maybe these things can't come from programmers, and I'd say maybe I'm not so pessimistic about that, and that like when we're doing API work, the programmers that like this is programmers have to communicate with each other, often across companies,
Yeah.
around what their APIs are. So is there a good reason to believe that we can't rely on programmers, or is this just about making it as easy as possible?
I think it's a combination of the two. I think to me, one of my guiding principles with everything I do is try to make things as easy as possible because people will always do the easiest thing. And I think that in the beginning of the Akita journey, so we're not saying very much publicly about what we do yet, but so far I've revealed it's about
And
APIs.
what
There's
is
something
what
around
is
software
what is
testing.
Akita?
Akita is my company. And yeah, so we're still technically a stealth mode startup. So what we reveal is we do something around APIs, we do something around black box software analysis. And in the beginning of the journey, I went in with much more strong assumptions about people's willingness to document and their knowledge of what was in their system already. So in the very beginning, I went to people and I said, okay, so you want to enforce policies on your data. Cool, I can help you do that. And they said, wait. We don't know where we have data. We don't know where the data is going. We don't know what software touches that data. And so then I thought to myself, okay, we need to take a step back. And that's how we started doing a lot of the work we're doing around taking software, taking it in a black box way and telling you this is what's going on. And then the next step was we said, okay, well, as long as you have an API and you know what that API is doing, we can tell you this is where you have stuff coming in, this is where stuff goes out, here's where bad things might happen. And they said, that sounds great. But look, we don't even know what's going on with our API. And so then we had to take a further step back. And so that's when I realized, man, um, should and could, and like the reality are very far apart when it comes to software. And I'm not blaming anybody. I think that's just how things go, right? There's I should floss my teeth twice a day, and then there's what I actually do, and then there's even how I floss my teeth twice or once a day, but my dentist doesn't think I do. So I think it's just the realities of life. Sometimes you have higher priorities.
Yeah, that makes a lot of sense. So really, and even if people are doing documentation, that'll only help the process, and they're
Right.
not
Yeah, absolutely.
upset to
So
have
what
feedback.
we've come across is there has been one company with really good documentation. I won't say who they are, but they have pretty good documentation, and they have only pretty good documentation, I think, on their external facing APIs. Their internal ones, I think it's a big question mark, and I think a lot of companies, if you think about a company that's moving fast, trying to ship stuff out, and the API documentation is not high priority, it's just not there. And then if you think about other software quality things, like how many tests do they have, what are they actually doing, I think it's very far from the golden standards of the programming languages community.
I I have a dumb a dumb question, or maybe a clarification. We're talking about modeling things,
Yeah.
but maybe it's not so clear as to why and how is that helpful in
Yeah,
the
that's
grand
that's a
scheme of things.
that's a great question. So I think that the reason of why that someone might actually care about is things like security, things like privacy, things like other catastrophic crashes that can take down your system. Um,
Yeah, but so like, uh, you model it in order to do something with that model.
yeah, in order to make sure that a bad thing isn't going to happen. So for the whole field of programming languages research, I would characterize it as you model what's going on in your programs so that you can know certain catastrophic things don't happen. And so for a lot of the classical work, it was about, catastrophic. The holy grail was like catastrophic operating system crashes, where if you had a spaceship and it had an operating system, there would be nothing that would just like explode the spaceship or something like that. So those are a lot of the classical use cases. When I became a grad student and I realized my interest was in building tools to give these kinds of guarantees at scale, I concluded that security and privacy was going to be the catastrophic place where that could happen. Because if you have so the way I think about software, especially modern software, is it's a big pile of bits. Like if you think about like back in the old days, if you read the books about, early MIT, Bell Labs hackers, their programs are like 20 lines long. There are these recipes, they're like cooking recipes that people could share around. They were not complicated. But now what software is it's this whole ecosystem. And so I described it at one point as it's a whole rainforest, not a single tree. And so taking any piece out or putting any piece in can disturb the balance of the whole thing, but you don't really know what's going on. And so there, I would say, in a modern software system, things that really can bring the system to its knees are, well, there's obviously things like, just like huge outages where there's like a bug that takes the whole system down. That's not what I work on, but that is one reason people model. And then the kinds of things I'm interested in are, does data go where it should, and does data go not go where it shouldn't? So a lot of these things, like these big breaches and these big hacks, part of it is like, well, the hackers are going to hack. There's always going to be hackers that find ways to break into your system. But the other reason this happens is there's just so many components in your software, and no one really knows where data goes. And so a lot of the existing solutions are like, let's inventory all of our databases and let's crawl all of our databases. Let's look in there and make sure that, things are where they're supposed to be. But you guys might be very sympathetic to my view, which is there's this whole pile of software that is moving data from one place to another. And if we can know what that does, we can shine a much better light on what's happening in our system with respect to these potentially catastrophic security and privacy issues.
So really, the kind of systems you're talking about, let's like we'll dig into the kind of rainforest analogy a little more. We're talking
Sure,
about
yeah.
tons of programs basically that are all running in different places in a network, and they're all talking to each other. And even the way that they're talking to
Yeah.
each other might be changing day to day. Is that kind of the situation that you're seeing?
Yeah, absolutely. So I would say that's the extreme end of the scenario. But if we take a very basic system, so how I got into the problem is this way. So for my PhD, I did this new programming model for automatically enforcing information flow security policies. So people in industry might just understand them as access policies or privacy policies. The reason they're called information flow is because they're about data as it interacts with the program, and not just data in a database or something like that. And I implemented the language, and then my advisor said, "Why don't we build some web apps to really demonstrate that this works. And I'm hosting a conference in a couple months. Why don't you just build a web app based in our language and host the conference using that? And very quickly, I realized there was a big issue, which is you can have your language in your application layer, but in a basic model view controller system, your your controller has to talk to your data models. And the minute you call outside of your application layer, what happens is all of the guarantees you got from your nice language level model are subverted, right? And so I had this nice language where you could attach policies about where data should go to the values themselves. So to like, if I have like credit card and only I should be able to see it, I should be able to attach that data policy to the piece of data wherever it goes in the program. That policy follows it. But the problem was whenever I called out to the database, there was no policy on the database. I could just do any database queries, and you can get all kinds of information from the database, and it completely breaks your thing. And it's even more subtle than just like querying the database for your credit card. It could be like, let's say no one's allowed to see my location. But then I can query the database on all people who are in Redwood City right now, right? Then there's an implicit leak of my information from of my location from that. And so there's just all kinds of problems when you go outside of your single application. And then if you think about what happens in your front end code, that again is a thing. So even before you have like this massive multi-service system, you get into some real issues with like heterogeneity and calling cross language. And then what starts complicating it is the minute you start getting a multi-service environment, you have those remote procedure calls. Every introduction to every information flow security paper that says, let's assume you have the system, you can call out to anything, you don't know where it calls, that seemed very impractical when you had like a 10-line monolithic piece of code, now becomes hugely relevant when you have this massively heterogeneous multi-service system.
And so it sounds like the conclusion you really came to was that from inside of the system, at some point we almost lose hope, and that. Oh, go ahead.
Yeah, exactly. So I had started my career saying, yeah, we're going to tackle everything in the application level language itself. We're going to extend languages. We're going to plug every hole. And I actually had this parallel line of research where I had done this dynamic enforcement for information flow security policies for my PhD. And then I had worked with Nadia Parlikapova on a paper where we did static enforcement of these policies and actually static synthesis. So we could insert access checks into your code from static checking. But we did this for liquid Haskell, which is liquid refinement types on top of Haskell. This is extremely limited because Haskell, first of all, makes extremely strong assumptions about what you have in your language, and then liquid Haskell further constrains that. And so then my next step was, okay, we'll do it for JavaScript, liquid refinement types on top of JavaScript. And then again, it was very limited. So I had this parallel research track where I was like, okay, we're going to tackle everything about programming, and we're going to handle, dynamically typed modern languages, and we're going to do all this automatic enforcement, and everything's going to work. And it was kind of like, I don't know if you've seen one of those scenes where someone's in a ship and it just keeps having holes and they're plugging up all the holes. And I felt like, man, like there's just always another case or there's just always something else to plug up. And so that's really how I got obsessed with the API layer, because to me, it was a way to start fresh. It was a way to start clean, because once you start getting into the game of taking every single programming language in the world, trying to clean it up so that you could enforce a thin level of guarantees on top of it, it just seems like, not just one rat hole, but like 1 million rat holes. Whereas if you can start one layer up, get clean guarantees from that, get, black box whatever you have in your application, meet those guarantees, have other models on top of that clean layer, like that actually gives you hope of modeling this whole thing.
Yeah. Have you done any one real challenge, I think. So there's two challenges, right? One is what is your API providing, and is it safe? And the other is, if I'm someone calling an API, am I using that in an appropriate and safe fashion. Have you looked at both sides of
Mm-hmm.
that, or are you sort of focused on one of those?
Yeah, so that's a really good question. So what we're doing at the API layer is we are providing tools to answer both of those questions. And so so really I see the first step in cleaning anything up as understanding. And so visibility is a term people like to use. What we're trying to do is give visibility to what's going on in your software at your API level. So, so both things you said is the API you're providing doing what you expect it to, and when I use another API, am I using that in a way that I expect it to? Both of those are questions we're working on answering, and it's still very much in line with my other where is my data going work. I think in general these are very hard questions to answer, but when it comes to is my API giving back the data I thought it was, am I giving my data to this API in a way that I expect, or is it processing it in a way that I expect? Those are the kinds of questions we're answering.
That's awesome. And so part of the goal is to detect problems, and part of the goal sounds like it's just to explain to people what's going on with their systems.
Yeah, absolutely. And I think that right now when people think about APIs or they think about data, they think of this as very, very one-dimensional in some way. Like when people think about data, they think about their database. And when people think about APIs, they think about, the one layer that is their API. And so when people talk about, data and access, they think about like, do I have like one thin layer of access control on top of my data? When they think about API security, they think about, do I have the right token checking at my API security level? But to me, what's interesting is what's always been interesting is the interaction of data with the rest of your software. And so when we say we're doing this at the API layer, that's the entry point for all of our black box analysis. But we're doing much more than looking at the API functions themselves. We're looking at, okay, if we hit the software through this combination of API calls, what's happening, things like that, and not just is this one API call secure.
So if we have anybody that's listening that's not familiar with the concept of black box, how would you explain that to them?
Yeah, so there are many levels, I guess. There's white box, gray box, and black box. And white box is full access to source code. You can see anything you want. You can analyze the code itself. Black box is no access. So it's the equivalent of, I don't know if you've ever had like a box of stuff in your house that you just keep moving from house to house, because you packed it at some point. You never really needed very much from it, but it like keeps going with you and it's just part of your life. So it turns out a lot of software kind of is like that, except people interact with that box and like they get stuff from it sometimes. um, and so that image is kind of what drove a lot of our desire to be fully black box. So we want to be able to take your software, not really need to access the source code, not need to understand what it does, but be able to poke at it and give you a summary of this is what you need to know about it. Because that seemed to me like a big part of how software development gets done is people are just carrying these boxes with them for their whole lives. And something like gray box is in between. So it might be you don't see the source code, but you get to instrument the code at the conditional branches. And so whenever a conditional branch gets triggered in the code, you know that happens, but you don't see the whole code. But yeah, I my dream is for everything to be fully black box. Like we don't need to get in there. We can just wrap the code, be like, all right, we like did these tests on it, and here's what the code is doing. Here's what you need to know.
And so when we look at the trade-offs, or really the advantage you're seeing with black box is that every system out, well, we won't say every, but the vast majority of the systems out there are heterogeneous in the sense that, like a bank, for example, will have its core program. Maybe it doesn't even have the source code for it anymore,
Yeah,
and it's running at the center. And then the next year they wrapped another layer around it, and then they wrapped a web API around it, and then that one talks to another one. And Blackbox lets you treat all those the same. You don't
yeah,
have to
yep.
worry, and you just go after them and figure out what they're doing.
Yeah, absolutely. So, yeah, a big motivation for all this is I gave an industry talk in 2015, and it was about the main thesis was there are all these great ideas we have in research, and I see you guys doing these practices in industry. How can we make it come together? And someone came up to me after the talk and they said, Jean, that was super interesting. But I mean, how do we get from where we are now to this world you're talking about? And then I dug in a little more, and somebody else said, well, a lot of what you programming languages people do is the equivalent of us going to the doctor and the doctor saying, well, if you had just eaten an apple every day and flossed your teeth and all these other things, then you wouldn't be in this position. So why don't you just start over? And what everyone tells me is, well, we can't start over. We already have all this legacy code. And even if we started over, we need some way to interact back with that. And so even if starting tomorrow, there was major unification of languages out there, it is, as you say, there's stuff that people built before. It's hugely fragmented. It's always going to be there. And then it's not just languages at the application layer, right? But if you think about data stores as their own runtime, and you think about front ends as having their own runtime, like the DOM, I've also done some work on information flow across, the DOM and the backend and things like that. And so you just have a lot of components no matter what. And if you're going to innovate in your tech stacks, there's just going to be more components. It's not getting better.
And we'll represent the other side of the trade-off, although it kind of obviously doesn't apply to the problem that you're trying to solve, which is that a lot of times there is source code around, and there's a lot we can learn from the source code.
Yeah, absolutely. Yeah, I think that when you have the source code, it's a much cleaner and more principled problem in a lot of ways. You have to just kind of cowboy your way through if you don't have access to the source code. But yeah, I think that since my goal is let's try to tackle as much surface area as possible as quickly as possible. That's how I came upon this view.
Thanks for tuning in for the first conversation of this 2-part episode. Please find the link to part 2 in the description.